Hello there, and welcome back. Finally, got back to my pet project, which is a picking robot. And I'm calling it picking robot because it's going to do exactly that. It's going to pick things. Um, and to start with, I prototyping a version of it that's very, very simple, driven by as a single board computer, a Raspberry Pi 4 with 8 gigs, and eventually a Jetson. Maybe I might stick with the Jetson depending on availability as they come back on the market. I have a few, but I wanted to find something that can easily prototype and use. And this thing has gone through several iterations from not having arms at all in the head and more of a vacuum to having arms in the head because I wanted to do a bit more. So I'm going to show you just a couple of versions of it and move on from there. So the original version was something like this, which I had a 3D artist do a little render for me as a finished product. I didn't like that it didn't have a head. I just like head. I think it's kind of weird without one. But the idea was pretty cool. You can see it has the arm movement that I was looking for, the end effectors that I was looking for, and the ability to change the end effector was quite important in this one. So we designed a little infector change tool mechanism to go on top of this. You can see it's a pretty decent design and definitely would look good outside. Where we got to was something a little bit more prototypish so that we can actually put something on the ground and make it work. And we're trying to decide between tank treads and wheels. So I've, as you've seen before in previous videos, have printed out some tank treads with a few motors and have that rolling on the ground, as well as a giant platform that's more like this that's also rolling on the ground. Today with ROS2 and NAV2. Now what I'm doing is building on top of that platform this this head, shoulders, and hands mechanism, or grippers, let's call it that. Grippers will have force sensors on them, so we can measure the force on the clothes, as well as just to have a bit of understanding of kind of object that we're holding in our hands. So we'll have that. This is a swivel point with a Hall effect sensor um, and motor. That's just one piece. I think I have one on the table here, so you can see that this motor like that, and it's got Hall effect sensor on the end. And then I also have here, and that's also here and here, so you can take a look there. And inside, I'll just take you up the arms. It's already are going up the arm. Same thing here, swivel point for that pivot arm like this. So we got an arm like this, and that also is here. So the idea is that it's going to roll along the floor. It's going to be able to bend at I guess you would consider this the abdomen or waist, and this bend point can take it all the way to the ground. And I'll just demonstrate that real quick, just for giggles. This whole thing's not connected, as I disconnected it so you can see. But if it were connected, the whole thing would fly to the ground. Disconnected it because I'm currently bringing this whole model in to URDF converter, which is a aftermarket program that you can install onto Fusion 360. I think some other content providers have kind of gone through that, so I don't need to go through it again. But once it's installed, it's under utilities and add-ins and your URDF importer, so I can kind of do that. Short of doing that, which does take quite a while, like for a robot like this is like a 2-hour period, I quickly built up a mock-up of the final robot, and here it is. I'll just drop it on the screen so you can see. And I mean, I basically just drew up some things. This whole thing took me 20 minutes, 30 minutes, as you can see by the fidelity here. a bunch of just grabbing a face and extruding kind of thing. I was more interested in the joints and the joint movement, and so when we got to the final robot, there wouldn't be any kind of issues with joint movement and things like that. You can see that there. I think I probably should have just created a rigid point here. I'll do that to some live stuff in front of you. So I'll just create a rigid group here and here, and okay, and now there you go. So yeah, that was the idea, is to just to get an understanding of just basically how things will work. Obviously, this would need to be the grounding point, so maybe not there. But for now, I'll just grab this so you can see that the whole head moves as it's supposed to swivel, etc. That. Okay. So there we go. We got the finished product of the robot, just like that. So just to, I guess, few things is in printing this robot. What I found is using a 3D printer that can manage the situation was vital. So I've gotten a 3D printer that can show me what's going on in the camera. Right now, I believe it's printing this part right here. So that was important. And just to get around the all-night printing and errors happening, I wanted to understand what the layers are supposed to look like at a given time. And if they don't look like that in the stream, I'll do something about it. So one of my next steps is to get the camera stream and do something with it. So I'm going to kind of measure what it's supposed to look like at a given time. If it doesn't look like that, I'm just going to stop the camera, particularly at night when I don't want to be sitting there watching it. Of course, I could have rigged my own camera system and done it that way, but it was easier to start out at least with this. Okay, so I think that's all I want to show for today, is the progress on this robot, and talk about a little bit of the technology behind it. ROS2, Ubuntu, Focal 20.04, and that's pretty much it. Starting with an Oak. Oh, by the way, this is an Oak D camera, which I found to be really, really useful on a robot like this, given that I didn't want to write a lot of code, and there was a whole lot of code already available to me on Oak's website. They have a little bit of examples sitting there. So the hardest part about getting this robot going was sourcing all the parts, given the lack of availability, and then once I had all the parts together, that's it. Everything is moving swimmingly in creating behavior trees and nodes and all of that stuff. Nav stack is Nav2, and I'm using the SLAM toolbox along with a stereoscopic SLAM algorithm. So that's the entirety of the robot. The next step is to actually finish the build, but I want to give you an in progress. And there's some things that I'm not exactly sure about. I'm going to be strong enough. Like I'm not sure about this arm yet, this shoulder point. So I'm actually building this arm out on a platform just to see if it can pull up the shoulder. And I don't plan on having objects in the hand that are massive when the shoulder's pulled up. I mean, the shoulder pulling up is more, not the camera. Shoulder pulling up is more for show than than any actual real function. And on the front here is going to have a display. Going to be some lights here and a speaker system probably embedded in here. There's still room in here. I've got a bunch of batteries, but the speaker system can go in here as well. The only thing really in here is the drivetrain for the wheels. And at this point, this differential drive, even though they're four wheels, they operate on two motors, so it'll run like that. And at some point, and again, if we use the tank treads for outside, what we might do is have a platform more like this little guy that I 3D printed, which will sit on top of the tank platform, and there's a space for a servo in there and a rotating uh, platform, if you will, if you want to know the, it's called a face bearing that will sit on top of this, and then a place for a lidar if we decide to go the lidar route. I'm trying to decide between understand the benefits to lidar given the the availability of this front facing camera. It's 120 uh, degrees field of view, and I don't plan on moving the robot without having cleared the space around it. So the this will rotate. This will rotate before we move the robot. So it'll move more like a head rotation to make sure it's clear enough to rotate this part of the torso, and then rotate the robot rather than having an extra moving part on the backside there, which will be opposed already, will oppose the field of view. And if I move this to the back and I put the LiDAR in front, then obviously the robot can't go down as far as it could. So if it sat here, it'd be a problem. If it sat down here, it would be a problem as well. All right, good enough for today. Thanks for watching. I'll see you soon.